Hello Cloud Pedagogians, welcome back to the course. In today's session, we will start understanding about networking on AWS. Looking back at the architecture diagram for student directory application, the part we want to focus on for this session of the course is this, means network or VPC. But before diving into the networking on AWS, we will recall the application. We launched an instance and connect to that instance over the internet. But to launch this instance, we needed to select a network. If you remember, we had configured this network, or VPC is actually what helps enable the internet traffic to flow into your application. You might be asking, how did we select a VPC when we haven't even built a VPC at all? Yes, you are correct. We haven't built a VPC. But fortunately, AWS creates VPCs for us in every region by default. When we launched our EC2 instances earlier in this course, we simply chose the default VPC. These default VPCs are meant to provide an easy way for you to get started with EC2 instances quickly and view your applications over the internet. However, you have to be careful with what you put inside of these default VPCs, as those resources will be subject to, the internet. As you know, with internet access comes potential dangers. If we did not select this default VPC, we would have needed to select a VPC that we custom built. In this session of the course, we will focus on doing just that, building a custom VPC for our application that is more secure and provides more granular access to the internet than the default option we originally chose. Here we are only focusing on the information which is geared toward EC2 related services. If you are using a different kind of compute such as Lambda function, you might not need a network at all. However, that doesn't mean this is not important. Networking on AWS is basic of most architectures, so consider this highly valuable. Now we will dive into some important network basics that you should know before jumping into networking on AWS. First, we'll try to understand what is networking. Networking is how you connect computers around the world and allow them to communicate with one another. In this, you have already seen a few examples of networking. One is AWS Global Infrastructure. AWS has created a network of resources using data centers, availability zones, and regions. Let's understand few more basics of networking. Think about sending a letter. When sending a letter, there are three pieces of information you actually need: the payload or letter inside the envelope, the address of the sender in the from section, and the last one, the address of the recipient in the to section. Let's go further. Each address must contain information such as name of sender and recipient, street, city, state, zip code or postal code, and the country. You need all parts of an address to ensure that your letter gets to its destination. Without the correct address, postal workers are not able to properly deliver the message. In the digital world, computers handle the delivery of messages in a similar way. This is called routing. In technical way, a computer network is made of many meshes called nodes and paths or links that connects those nodes. Communication between two nodes is an interconnected network can take place through many different paths. Routing is the process of selecting the best path using some predetermined rules. So, what are IP addresses? In order to properly route your message to a location, you need an address. Just like each home has a mail address, each computer has an IP address. However, instead of using the combination of street, city, state, zip code, and country, the IP address uses a combination of bits, zeros, and ones. In the network, IP stands for Internet Protocol. which is a numerical label that is connected to a computer network and uses the internet protocol for communication. As you can see here, it is 32-bit address in binary format. It's called 32-bit because you have 32 digits. Next, we'll try to understand what is IPv4 notation. Typically, you don't see an IP address in this binary format. Instead, it is converted into decimal format and noted as an IPv4 address. There are three notations to show an IPv4 address. As you can see here, binary notation, dotted decimal notation, hexadecimal notation. The three notations to show an IP address are diagrammatically represented as you can see here. In binary notation, IPv4 address is displayed as 32 bits. To make the address more readable, one or more spaces are inserted between bytes. In dotted decimal notation, IPv4 addresses are written in decimal form with a decimal point separating the bytes. Each number in the dotted decimal notation is between 0 and 255. In hexadecimal notation, each hexadecimal digit is equivalent to 4 bits. This means a 32-bit address that has 8 hexadecimal digits. This notation is often used in network programming. As you see in the diagram, the 32 bits are grouped into groups of 8 bits, also called octets. Each of these groups is converted into decimal format separated by a period. In the end, this is what is called an IP address. This is important to know when trying to communicate to a single computer. But remember, you are working with a network. This is where CIDR notation comes in. So, how to use CIDR notations or CIDR notation? Here you can see a single IP address 192.168.1.30. If you want to express IP addresses between the range of 192.168.1.0 and 192.168.1.255, how can you do that? One way is by using the CIDR notation, which is classless inter-domain routing notation. CIDR notation is a compressed way of specifying a range of IP addresses. Specifying a range determines how many IP addresses are available to you. CIDR notation looks like this. It begins with a starting IP address and is separated by a forward slash followed by a number. The number at the end specifies how many of the bits of the IP address are fixed. In this example, the first 24 bits of the IP address are fixed. The rest are flexible. 32 total bits subtracted by 24 fixed bits leaves 8 flexible bits. Each of these flexible bits can be either 0 or 1 because they are binary. That means you have two choices for each of the 8 bits, providing 256 IP addresses in that IP range. The higher the number after slash, the smaller the IP addresses in your network. For example, a range of 192.168.1.0/24 is smaller than 192.168.1.0/16. When working with networks in the AWS cloud, you choose your network size by using the CIDR notation. In AWS, the smallest IP range you can have is /28, which provides you 16 IP addresses. The largest IP range you can have is a /16, which provides you with 65,536 IP addresses. Alright, we have learned foundational elements in networking. In next video, we will understand networking on AWS, nothing but with VPC, which is Virtual Private Cloud. When you are ready, please join me in the next lecture. Until then, take care.